In this video we're going to discuss about superheated vapor, and in the diagram is this region. So this happens, for instance, when the temperature that any given substance has is larger than the temperature in the saturation region. It is also superheated vapor if the pressure of saturation is larger than the pressure at a given temperature. So we have two rules. The given temperature is larger than the temperature of saturation, or the pressure of saturation is larger than the pressure at a given temperature. Table A6 gives superheated water data, the specific volume, for instance, and internal energy, enthalpy, and entropy. You first start looking for pressure here. This is the pressure, and this in parentheses is going to be the saturation temperature. So for instance, at 0.05 megapascals, its saturation temperature is 81.32. Here, the first data that you have is the saturation data. That saturation data is for saturated vapor. For instance, at 0.01 megapascals, at 45.81 Celsius, which is the saturation temperature, well, all of these properties are going to be for saturated vapor. Larger temperatures, if the temperature is increasing, larger than the saturation temperature, it means that it's overheated or superheated. So larger temperature will mean as well larger volume, larger internal energy, larger enthalpy, and larger entropy. So the third rule in order for us to understand is that any given specific property, so any specific property should be larger than the saturated vapor specific property. In order for it to be superheated. So three rules once again: larger temperature than the saturation temperature, lower pressure than the saturation pressure, and any given specific property larger than the saturated vapor specific property. Then it's superheated.